All right, everyone, let's go. Hi, everybody. New meetup from the ING Backend Guild tonight with Michel Schudel. You might know Michel from his talk about cryptography at Devox. You might also know him from his talk at JFocus or the battle between Quarkus and Micronaut. But he's also one of the organizers of the Utrecht Java user group. So tonight he's going to talk to us about unit testing your software architecture. A few things really quickly. Ask your questions anytime in the comments. It's actually easier if you ask your questions earlier because there is a delay of about 20 seconds between the moment we receive them and we can answer them. So don't hesitate to ask. Michel is going to talk for about 30 minutes and there's going to be a demo as well. And that's about it. I hope you enjoy the show. Here is Michel. Hi, Michel, welcome. Let me put you up. There you go. And you're ready to roll.
Yes, thank you very much, Julian. Okay, so welcome everybody. Thank you for joining in this little webinar that we've set up on behalf of ING. I'm really honored to be here. Today we're going to talk about ArchUnit. ArchUnit is a tool to unit test your software architecture, so we're going to see the highlights of that and a little demo as well. And after the talk, I will look at the comments and see if there's any questions you have asked that I might be able to answer. Okay. So on the bottom left there is my Twitter handle. So if you want to follow my tech ramblings on Twitter, please follow me. More followers is always awesome. So go there. Little bit about me, as short as possible, if I can get it working. Yeah. My name is Michel Schudel. I've been a Java developer for about 20 years now. I've seen all kinds of normal and weird stuff in those days. That's a picture of Greece, actually. We wanted to plan to go there next week as well. But as you might have seen on the news, that's code orange. So my vacation is basically down the drain. So I have to organize something for the next few weeks, some alternative thing, but I'll manage. You can reach me on michel@craftsman.nl or my Twitter handle. I'm working as a Java consultant for Craftsman, a small company. Actually, those in the photo are all the employees. And we are consultants that try to I have to hide this. That's better. Yeah. That try to solve complex problems with a variety of clients, including Belastingdienst, Dutch Railways, Bol.com, Kadaster, ING, of course, and Rabobank, which is also where I work right now, but please don't hold that against me. I like to give talks on conferences as well. So I've been on Devox, Java Zone, JFocus, Java 1, and of course the NL-JUC conferences where I talk about cryptography, Quarkus, Micronaut, stuff like that. So if you're interested in that, look me up on YouTube and go see those talks if you want. But as before mentioned, today we're going to talk about ArchUnit. So I would like to start with a little story I want to tell you. So I'm a consultant, so I go on a variety of different projects. So the first day you come in you come into a new office and go work on a new project. There's always an introductory day where, among other things, you get a session with the architect or software architect to explain to you what the system is all about and how this is implemented. So I went into this room and this guy took a whiteboard and drew a very clear picture of how the software system actually worked. So that was all fine by me and it was very clear. So then I asked him, okay, so show me a bit of code that actually reflects that. So I'm really interested in how does this look like in the code? What do you actually use? And he was like, well, you have to ask the developers that because I only draw diagrams basically. So this might seem familiar to you. This is called PowerPoint Architect, right? So these are people that do fine work in design and schematics and diagrams, but maybe not as good as being able to reflect that in the code. So I said, okay, well, that's no problem. So I got my Git account already. So I opened up a repository and I went to look into the code. So I checked out the code and that all looked very nice. And then I got my notebook and tried to remember what the architect had talked about. And I tried to correlate the code and the architecture, but no, not really. So I couldn't really correlate what this guy had drawn on the diagram with the code that was in the repository. And that was because the architecture was actually drawn up at some point in time, but only the code evolved, and because there were new functional requirements or new non-functional requirements, and the code had drifted away from what the architecture was originally meant. Doesn't mean that the code was bad, it just meant that there was a gap between the design and the code itself. So, of course, what happens is when your code evolves, your architecture evolves as well. Martin Fowler wrote a letter to Ralph Johnson, and basically Martin Fowler had a very clear definition of what an architecture should be, or actually it was Ralph Johnson who said that. And he said, well, architecture is a shared understanding between developers about a system's components and their responsibilities and relations. So that basically means that architecture is essentially a set of responsibilities and relations that all developers understand, and everybody has the same picture of that. Now, of course, when you're developing functionality, architecture is not something that is static. So architecture is evolving. That basically means that architecture has to evolve with the functionality of your system. Evolving code we can handle very well already. So like we have unit tests, right, and integration tests to still see if all the functionality holds together and if everything still works. So we have pipeline for that, automatic testing tools. Now, wouldn't it be very interesting or very nice to do if you could do the same with the architecture? So to see if this still holds up to the functionality, and if it's still implemented correctly in all the applications, all the microservices, etc., etc. Now, fortunately, you can, because there is a little tool for that. It's called ArchUnit, and it basically enables you to write your software architectural constraints as unit tests. So ArchUnit has a couple of properties, which makes it very easy to work with. As we will see also in the demo and in the next slides, ArchUnit tests are normal unit tests. So you can just run them from the IDE or from Maven, Gradle, whatever. And of course, they go into the Git repository because it's just code, so you can version them very nicely. As we will see in a moment, it has a Fluent API, so it is really easy to write some tests that you can actually understand what happens. It has support for JUnit 4 and JUnit 5, and I think Spock also as well, but I haven't really tried that. If you cannot, if the normal API is not enough for you, you can extend ArchUnit with your own custom rules. And it is completely open source. So if you have any pull requests that you think might improve this little library, by all means, go ahead. So the GitHub link is there below. So if you have a pull request, you can just put a pull request there. Now, it's important to mention the scope of ArchUnit. So ArchUnit checks Java software architecture constraints. That means it checks constraints within one application or microservice. It does not check architecture rules across network boundaries. So, for example, if your architecture, of course, also talks about microservice A should not be able to access microservice B or only in so-and-so fashion, that is not something ArchUnit is meant for. So it is really about keeping the software architecture of your Java application intact. So that is the scope, and we will see a couple of examples of that. So let's get started. So getting started is really easy. So if you use the Maven build system, you can just plug in a dependency in scope test, of course, because you only need test scope. And this is an example of ArchUnit for JUnit 5. You can probably guess what the JUnit 4 version looks like, so I'm not going to tell you that. And if you're into Gradle, you can use it as well. So that is basically the same way. You can include a test compile dependency that will enable you to use ArchUnit in a Gradle context. So getting started is basically really easy. Okay, so ArchUnit has a number of check categories or check types. I've listed a few here, so I'm gonna package dependency checks, class dependency checks, and basically a number of other ones. And the ones on the bottom, layer checks and cycle checks, are the more interesting architecture-wise. I'm not going to go through them all, because if I've shown you a few, you will probably get the hang of it. So today I'm going to talk about just 4: package dependency checks, class dependency checks, annotation checks, and last but certainly not least, layer checks. So let's see how this looks like. So let's take an example. So for example, if I were to have a microservice, for example, small Spring Boot application that contains 3 packages: API, core, and clients. So the idea would be that core contains the core business functionality, so the domain objects, the logic around that. The API would be like the package for your REST controller, so you could actually access this business logic from somewhere. And the client package would be interface implementations going to outgoing systems. So for example, if in core I were to have a external address service or something like that, I would write a client, and the client implementation would be in the client package. So that's basically my simple Spring Boot application structure. So now what we actually want in this architecture is that API and client should be able to access core, but not the other way around, because it would be really strange if core would have a dependency on an outer layer, for example, the API, and also a dependency on the clients, because the core should be a self-contained thing with its own business logic, and you should be able to test it in isolation. So if you wanted to write a validation or check for that in ArchUnit, so what would that look like? Well, it would look something like this. So you basically write a normal unit test class. It's called ArchUnit JUnit 5 test here. You annotate it with an annotation called analyze classes, and you specify a root package. So what that basically does is that all classes that are in this package or below this package are included in this validation and will be tested against this rule that is written here. So for this unit test, I've only written one Arch rule. It's the field below. It's called package rule. It's annotated with the annotation Arch test. So basically JUnit 5 will pick this up automatically and will run the rule according to the specification that is written. So this is just an example of the constraint I was just talking about. So you specify that as no classes that reside in a package core should depend on classes that reside in any package, API, or client. So that's basically pretty straightforward, right? A couple of things to mention here. You see 2 dots before and after validation, provided, of course, that is included in the root package that is defined in the analyze classes annotation. So that's one. You can also specify the complete absolute package name if you want. So you can also do something like nl.ing.core. Whatever, but for this example, I've taken a wildcard because it strips away a lot of the boilerplate stuff that you, for this demo, don't really have to care about. The other thing is there are no test methods here. So there's only the class and a rule or a set of rules. So you don't have to write any specific test methods for this. You can just specify a package rule, and it's basically really a declarative style Fluent API, which makes it very easy to work with. So now you might wonder what is in this Fluent API actually, because you see here no classes that reside. Well, there are probably a lot more possibilities, right? Yes, of course, but I'm not going to tell them all. Just let the API guide you, okay? So just go into your favorite IDE and use code completion, and you'll see there are a lot of possibilities there that you can use to string together validations. So just include the library in your microservice and just go explore, okay? So that was an example of a package dependency check. Now I'm going to show you an example of a class dependency check. So we have 3 classes here. There's one class called foobar, and there's a class called bar, which accesses foobar, and there's also a class called other, which also wants to access foobar. So, for example, if I would have an application where the class called bar should be able to access foobar, but the class called other shouldn't be able to access foobar, how do I specify that? Something like this. So you say classes that have matching name .bar, so you can use wildcards here as well, should only be accessed by classes that have simple name bar. So basically the specification is the other way around, right? This means that if you were to program a class called other that directly accesses foobar, you would get a unit test failure. And I hadn't mentioned this, what happens if a test fails, but it's a normal unit test failure. We will see this in the demo, okay? So this is an example of a class dependency check. So you also have annotation checks. So for example, this is a familiar pattern. So if you have a class that does something with a database, right? So a class that uses an entity manager, you probably want to have certainly in a Spring Boot or a JEE context annotation, you want to have the annotation transactional on top of your class or methods or something like that. Probably otherwise, you probably would notice that it wouldn't work in an integration test, but nonetheless, you can also explicitly check this. So you can scan for classes that use an entity manager but do not have the transactional annotation on them. So you can specify that like this. Classes that are assignable to entity manager class, so that basically means entity manager class or a subclass of that, should only be accessed by classes that are annotated with transactional class. So this is a way that you can specify which classes should have which annotations. So that's very handy. So this is all still a little bit, these are still a little bit checks that could also have done with, for example, maybe check style or PMD or find bugs, which doesn't exist. It's called spot bugs now. You could probably have specified it in one of those libraries as well, although not so nice as this. I think it would probably be more XML stuff like that. But where the really added value of ArchUnit comes into play is in architecture and layer checks. So let's go back to the example for a moment. This is the micro application I just specified, and it still has the same constraints. So basically constraints from outside in, but not from inside out. So how do you specify this? Well, you've already seen you can do this with packages, but you can take this one step further and basically specify layers. And that looks something like this. So what happens here is you start the layered architecture validation, where you first define your layers. So for example, a layer API is defined by a package that contains API, but you can specify multiple packages here. And then you can, once you've done that, you can specify the constraints. So it says where layer API may not be accessed by any layer, etc., etc. So it's basically the same check as the package test, only there's a level of abstraction here. You can specify multiple packages here and really talk about how your software architecture layering should be constructed, right? So this is a very clean way to specify what layer should be able to access other layers. Now, of course, this is not something I just came up with. This comes from a familiar pattern, which is called the onion architecture. So for those of you who don't know what it is, it basically specifies that you have a application core, which contains your domain model, your domain services, and your application services. And that is a cohesive whole that can function all by itself. So in order to do something with this core business logic, you can use tests, for example, which access this business logic, or a user interface, or, for example, infrastructure like REST controllers. And the idea is that this architecture you can peel off like an onion. So I would strip away the user interface, infrastructure, and tests, and the inner sides will still work as a cohesive whole. So that's the idea of an onion architecture. So dependencies from the outside to the inside, but not the other way around. Now, ArchUnit also has a really handy shorthand for this, and it's called onion architecture. So this is basically another abstraction on the last test I showed you, where now you don't have to specify the layer constraints anymore, but just specify what the layers are. So in this case, my domain models, domain services, and application services would all be in core. And I would have an adapter, which is in clients, and an adapter, which is an API. So these are the outer layers. So this would be enough to specify an onion architecture and make sure the constraints are validated. So no dependencies from the inside out, but only dependencies from the outside in. So that's a really cool shorthand for testing an onion architecture. Now, if you can't specify a constraint using the standard Fluent API, and believe me, you can specify a lot in that, you also have the option to write custom rules. So this is an example. So for example, I would like to have a rule that checks if there are no more fields annotated with deprecated in my code anymore. Otherwise, I wouldn't be able to check it in or something like that. So what you can do is you can extend the interface ArchCondition, and then you can override a method called check. It has two parameters, a item parameter, which is of type Java class, which is basically a kind of reflective model of your class, only a little bit simpler, so you don't have to hassle with field methods, stuff like that. And there's also a parameter condition events that you can use to add validation errors. So for example, if a class has deprecated fields, I haven't written the logic here completely because it is a lot of code. It's not really important for the example. But if a class has deprecated fields based on this item model, you can add a violation to the events parameter and say what the problem is. So if you run this in your IDE, you'll see that it will show up nicely as a unit test failure with the appropriate comments, so you know what's going on. So now, in order to use this, you can just write an Arch rule. And this is an example. So classes should, and in the should method, you can also inject this basically this predicate-like interface. So that would be enough for you to use custom rules. Now, you probably have seen that this ArchCondition thingy looks like a little bit like a functional interface, right? Or a predicate or something like that. So can you use actual lambdas in ArchUnit? Sorry, not yet. So it's not there yet. It would be a really nice addition to the API, I guess. So if you're anxious to do this and you want to write a pull request to actually make sure that you can also use lambdas in ArchUnit, it will be very nice. So go to the GitHub link I showed you earlier and file a pull request, and it will be a nice addition to the language, but sorry, to the library. But it's not there yet, sorry. So you have to do it like this. So that is a little bit about custom rules. So now we work at Rabobank. We already work with ArchUnit in a few of our teams. So what happens if you want to have checks that apply to multiple teams and multiple microservices? So I'm not talking about the nitty-gritty stuff that every team does a little bit differently, right? So this is about the layered architecture, for example. So you want to make sure that everybody in your tribe or in your squad uses microservices and builds them the same way as maybe the 2 or 3 teams you work together with, right? So you have a consistent whole. So now, of course, you can duplicate all your ArchUnit checks, no problem. But it would be also very nice if you could maybe share them across a few teams. And I'm not trying to say here you should have a shared artifact in your whole department or something like that, because it's not going to work, I'm pretty sure. But if you could share some checks between some teams, that would be very nice, right? So how would you do this? Well, this is one way you can do it. You can write your ArchUnit rules in a Java file, and you put it in scope compile. Otherwise, the test scope will not be picked up by artifacts that will depend on this. You have to use compile scope. We will see in the demo as well. And after you've written this artifact, you can just use it as a test dependency in your own application. So other people can use this test dependency in their own application as well. So you can share rules in that way. Now, in order to run these rules, because they're in a shared artifact, you have to do a little bit of configuration in the build system. So for example, if you were to use Maven, you have to tell the Maven Surefire plugin that it should also include the tests that are in this NL :my_arch_test:100 artifact. Because the default behavior of the Maven Surefire plugin is you just write the tests that are in your own artifact. So that's a little gotcha that you have to take into account. But there's an even nicer way. What you can also do is write an ArchUnit rule that includes other rules. So in this case, you can say, you can write an arch test in your own application, in your own test package, and then you can say, okay, I'm going to refer to this archrules.class in this other artifact. So in this case, you make it explicit. If you ask me what is the nicest way, I really like the bottom one, so the arch test, because you really make explicit that you want to run these other ArchUnit tests. And I'm pretty sure someone will probably forget at some point in time that they have to configure the Surefire plugin and don't understand why these shared tests aren't running. So that's always a gotcha. So I really like the bottom one. So we use that as well. So what happens if you introduce this framework into your department or in your tribe? So you already have an existing system, right? So you take this existing system and you write an ArchUnit test and you put it through there. And what happens? Of course, yeah, you get mountains of violations. Probably we did. So there's two ways you can solve this. You can try and fix them all, which might take you a lot of time. But you can also try to only fix stuff that is new, at least for starters. So how do you do this? Well, fortunately, ArchUnit has a class that is called freeing_arch_rule. And what this basically does, it says, okay, I'm going to run the ArchUnit tests now, and I'm going to record all violations, and I will store them somewhere. And on subsequent runs of this ArchUnit test, I will see if there are new ones. If there are new ones, I will report them. If they were already in the previous run, I won't report them anymore immediately. So that gives you a nice way to deal with incremental violations and just at least initially solve only the new stuff that only solve the new violations, right? Now, ArchUnit has an interface for this. It's called the violation store. And right now there's only one implementation. It's called text-based file violation store, and it basically records all violations in a text file. So yeah, that kind of works, but of course it would be nicer to, for example, compare this to SonarLint, for example, to see only check violations that are in files you're about to commit, right? So really new stuff. So there is no implementation for that out of the box, but nothing holds you back in implementing a violation store implementation that does something like that. So we haven't done this yet, but that certainly doesn't need to hold you back in writing a new implementation. So ArchUnit is able to handle evolving checks. So enough talk. I guess we should demo a bit, because otherwise it might not really stick for you. So let me open my favorite IDE, which is, no, it's not Eclipse. I hope everybody can read this. I will magnify this in a moment. If the code shows up.
Do you maybe want to answer the questions first, or do you prefer to do the demo directly?
I will do the demo first, I guess.
Yeah? All right,
yeah.
No worries. Keep going.
Yeah, thanks. Okay, so I have a really simple Spring Boot application here. So for people of you who work with Spring Boot, probably nothing new here, right? So I have the three packages here I talked about earlier. So I have an API that has a controller, which is basically a REST controller, that goes to a service that is in the core package. You can see it here. And the service also has a client. And of course, this is an interface, because if you want to have the onion architecture, you can depend on an interface, but not on the implementation. So the interface is actually in the core package, and the implementation of this interface is in the client package. So this means you have no compile time dependency on client, only runtime, which is what you want. So the client is an interface that basically also does an echo, and there's a really simple implementation here that basically does nothing, right? But you can imagine this goes to an external system of some sort to get some interesting data. So that's a really simple application. So now let's go proceed and test its architecture. So I have a test package here that has a couple of ArchUnit tests. So let's start with a really simple one. So I have one here that's called REST controller annotation tests. So I already specified, okay, you have a root package that you have to specify. So that's really easy in my case. And then I have a REST controller naming rule that basically says classes that reside in the package API and have simple name ending with controller should be annotated with the REST controller. Now, you can also put in the REST controller class here directly, but I prefer to not have too much dependencies on annotations within my ArchUnit tests. So I can run them from any artifact I want and won't have to hassle with the dependencies and still can run the validations. So let's run this for a moment. So this is just a normal unit test, like I already told you. So there it goes. It spits out a lot of stuff about analyzing classes. Basically, it lists all classes that it will take into account, which is basically everything that is in the library itself and in my own application. So what is in the end is really interesting. It says nothing, right? Because everything is green. So you don't have to worry about anything here. But now I will introduce a mistake. So I have a REST controller here, and I will forget to put the annotation on it. Now, of course, probably your integration test will pick this up as well. But just to see what happens when you run this test, I'll show you again. Yeah, there it goes. So you can see here at the bottom that it actually gives a, well, pretty nice error message. It says there's an architecture violation here. And it says rules that reside in a package API ... So basically that's the string representation of what I wrote here. And it also says that it is in the hello controller is the problem. It doesn't set which rules, probably because it's outside the class. But at least it will give you some indication of what is actually wrong here. So, so this spits out a nice error message. So I will put this back for a moment to fix my error. And let's look at another example. So what might be a little more interesting is the package test. That's basically the first test I showed you. So basically this tests that you could have dependencies from API to core and client to core, but not the other way around. So if I were to take the service and, well, auto-wire, well, actually I don't even have to do that, but let's do that for consistency's sake. I would use a hello controller here. So, oops. Of course, you can all agree that this is not something you should do, right? Because now you're going from your core package to your API package. So thankfully, this package test will pick this up. So if I run this, you will see that it also fails. And basically another architecture violation, which basically says no classes that reside in package core should depend on any class that reside in package API client. It was violated one time in this class. So you will get information about this violation as well to see what's wrong. So, okay, so those were two tiny violations I wanted to show you. So now let's look at the bigger whole for a moment. So in this POM, I have a no, I'm not going to talk about that. I'm going to talk about the shared tests issue. So I showed you earlier that you can reuse tests between applications. So I have an artifact here. It's called shared architecture tests. And in the main class, it contains a test that tests these onion rules. So you can reuse this across teams. So I have a layered architecture rule here that basically does the onion check by layer definition. And I also have the onion model rule that basically tests the same thing, but in a shorter way, right? So I hope that's pretty easy to understand. Oh, I even have it twice, I see. Well, never mind. So a couple of important things you have to notice. You have to include an import option. Do not include archives and do not include jars here. Otherwise, it will include all dependencies that are below. So you want to specify what actually has to be tested inside your application, not in the shared artifacts. So please, in shared artifacts, always put this on top. And if you look at the POM here, you will see that I have a compile scope to ArchUnit, because otherwise I can't access it in the other artifacts, and some Jupyter API scopes. So I have unit test scope. And the only thing I have to include in my application is the shared architecture tests artifact in test scope. So this is a way to be able to reuse architecture tests across applications. Now I've used the Surefire plugin trick here to tell my application that it actually has to run these tests, and I will show you that it actually works. So if you can, where it is, yeah, it's called shared architecture tests here. So just remember the name. For example, layered architecture rule is a shared test. So if I run all the tests in my application test package, which I'm going to do now, yeah, you will see that it has run the tests that were already here, but also let's see. Yeah, also this shared test. So it has the layered architecture rule here, the onion model rule, which comes from the other artifact. And now I'm pretty doubtful because I also use the other method of including stuff. So I really don't know now what triggers the run of these shared tests. But you have to include one or the other. Okay, so you can use this. So you can use an explicit import if you like, or you can use the specification that you have to run the tests as a in shared artifact. So you can do one or both. You can also do both. Doesn't matter, but it's a little bit too much. But for this demo, I included them both. So I guess that was the short demo. So let me get back to the presentation for a moment. And we're already at the end. So to summarize, I guess ArchUnit is a very nice addition to your project to enforce software architecture constraints. It has a unit test format, so it's easily runnable from build systems or your IDE. That's very, very handy. And if you want to share tests between applications or microservices, you should make a separate artifact so you can share stuff. Of course, you can also duplicate stuff, but sharing is easier. So that was all I had to tell for my presentation. Yeah, so now we get to the Q&A. Before I get to the comments, if you want to play around with ArchUnit yourself, there is a GitLab link here that you can use. So you can just check it out, and it contains all the tests I just showed you, right? So have fun with that. Let's see, we still have some time to look at the comments, so I'll open that for a moment.
Would you prefer you read it yourself, or do you want me to read them for you?
You probably looked at them already. So if you see something that seems relevant, please read them to me.
We have two questions mostly. The first one is, why would you do ArchUnit tests knowing that you can limit access to things using the manifest in the later versions of Java? I guess.
Okay. Okay. Thanks for that question. So I guess let's see. Christoph was that. Thank you for your question, Christoph. Yeah, it's a little bit to communicate bidirectionally now, but I think maybe you're talking about modules. So if you're not talking about modules, please type. Yeah, you could do that. You could restrict some stuff there, and also you can use, of course, Maven artifacts to restrict stuff even more. But for example, at Rabobank, we don't use that at all, modules. And we like to use as much code in one Maven artifact as possible. So in that way, we use ArchUnit that you can, in that case, you can still use ArchUnit tests to, you can still set up your constraints so that people don't cross any boundaries you don't want them to cross. And of course, I guess you can restrict some package stuff, but if you go to the, for example, the annotation checks or class dependency checks, you might have some more options in ArchUnit than you would have with restricting them to a manifest or the module system. So, okay, that's one question, I guess.
Yeah, and the second question was from Jorun, and Jorun was asking, what if part of your architecture is written in another language that is or not based on the JVM? Can you stretch the ArchUnit to handle that or not at all?
Let's see. What if parts of our unnecessarily built without languages are not part of the JVM ecosystem? Well, I guess when you're not on the JVM, this won't. Yeah. So basically, are the boundaries. So you're probably talking about mixing in Kotlin or something like that, right? Or Scala. Actually, I haven't tried it before. I don't really know. My best guess would be that you would end up with class files anyway, which is what the analysis is done on. But if you want to know, you could go to the reference documentation of ArchUnit and see if is there anything there. There's probably something there, but I have to be really honest. I don't know by heart if this is the case, but I can imagine that going over. So, for example, putting in non-JVM languages in scope, it will probably not work for that.
Okay. I think you touched it. I do have a question myself. I have never tried ArchUnit yet.
Yeah.
You did mention there is absolutely no IDE integration, because to me the best usage would actually be live as I write code, this thing telling me no, you're writing it in the wrong place, or you shouldn't be doing that, right? I mean it's because right now you're doing that afterwards, right? Your commit is already done. It's your post commit hook handling that. I'm guessing, unless you run locally, but it's after you write code.
So basically, you want to have some sort of REPL pattern that you as you were writing code, it will immediately warn you you shouldn't do this or something like that, right?
It's like a Sonderlint equivalent.
Yeah. Well, I guess that would be a nice plugin.
Oktoberfest is coming, right? So.
Yeah, exactly. I'm pretty sure it's not there yet, but I know what you mean. For example, when I write some front-end code, I also have npm tests run in the back to see if I make any mistakes, and it just continuously warns me of any problems I might make, right? So yeah, I'm pretty sure that there's not something like that there yet, but that would be a nice plugin for IntelliJ, for example.
Yeah.
That's a very good question or suggestion. Thanks.
All right. As far as I know, we do not have any other questions, so we might actually close a little early. I think if it's okay with you, Misha, we'll send an email after the event for all the attendees so that they have access to your GitHub, but also the slides. Maybe can you share the slides? Yeah. Okay.
Of course.
An email with everything.
Yeah. Okay. Thank you very much, Julian. I'd like to be. It was very nice to be here, and I hope the people enjoyed it. I see. If there are any more questions, for example, Christoph, I see the word modules eluded me. Please contact me on Twitter or through email or something like that, so we can have a chat. Maybe I misunderstood. There's one more personal thing I want to say. If my presentation actually wants to, yeah.
Yes.
I didn't expect that we would be as we were where we are right now in January or February or something like that. So it's pretty strange days. We're all working from home, but I sure get a lot of energy in delivering these kind of knowledge sessions, and I hope you get the same amount of energy receiving them or even giving them. And if you're really bored and you're bored with Netflix, you can go out and get a secondhand DVD of this movie. So it is called Strange Days. Actually, it's a little bit old, but it talks about a lot of the stuff we see today. So that's a little tip from me. So I enjoyed being here. Thank you very much, and hope to see you at a live conference very soon, or otherwise in a webinar. So thank you.
Thanks for joining, Michel, and see you maybe for the others at another meetup. We should have one before the end of the month, I guess. So see you, everyone, and we're checking out. Bye-bye.